So the first part, you heard my first two parts last time, and then is part 3, how we make patterns. We can make patterns like this one. This guy is just using his leg and his some kind of primitive device just to cut the sticks, put them together, and so on. The people in the past were not really educated like you are. You went to primary school, you went to high school, you went to the university, you were learning a lot. Most of these people didn't know how to read. Believe me, they didn't know how to read. And still they made these things. So we have to be really clear. They did not constructed these patterns. They just implemented them in the wood or marble or something. But there were people behind of this who were designing these patterns, and most of them were architects or mathematicians or both. In one of the old papers, there is such a text. There was a meeting of a mathematician, Abu Afa al-Buzjani, with architects, and they spent the whole night designing polygons, not patterns, polygons. That's a strange thing. What they were doing, they should do patterns. No, they were designing polygons. You will see why later. So be sure that with the patterns, there is really much more than we really know. There were really very clever people who were designing these patterns, and this is really deep geometry. This time, this is 12th century and slightly up. This was the best development of geometry in the Muslim world. You see, what happened really in the history, oh, that story is quite long. I don't wish to put the story here because when the Byzantine Empire collapsed, and Byzantine Empire, it were Greeks, when they collapsed, the whole knowledge was captured by Muslims, and they started developing it further. And this was the period when they were developing a lot of geometry, simple geometry. In the West, no one knows this. In the West, people know about Western geometry and nothing else. So remember, there is a huge heritage behind all this. There are many different methods of making these patterns. Everybody is saying, oh, that's a traditional method. The only question, what means traditional? 20 years old, or maybe 100 years old, or maybe 500 years old. For everybody, tradition may mean something different. When Muhammad was here, Al-Janabi, he was telling, oh, my father was doing this way. So for him, this is traditional way because his father was doing, his grandfather was doing, okay? But is this true that his father was using the methods from the 12th century? We don't know, okay? So very often you hear people saying, I use traditional methods. Be careful with this because traditional method may mean for everybody something different. In West, we have something that we call point-to-point method, and if you really want to see Issam al-Said, I will show you later this title. This is the best example where you can find something like this. When you turn to Morocco, in Morocco you will find a few local methods developed by their own craftsmen, mostly craftsmen. They don't have really a kind of general method. These are craftsman method. So they have Hasba method, very strange but very interesting. they have Zilic method. This is also Moroccan. Then there is something like the Kundekari masters do. Kundekari masters, they know each shape. They know these two sides are equal, these two sides are the same, this angle is 90 degrees, this one is something, okay? So they know these shapes, and most of the Kundekari masters use just the shapes to assemble their patterns. When Ismet was here, he told you, I don't know how to construct patterns, but I know how to make a pattern from something that I saw somewhere. Okay? So they can, just looking at the pattern, copy it, because most of the patterns are using typical shapes. There are patterns where shapes are unusual. And this is what is the most interesting for me. I'm not really interested in patterns where you're getting typical solutions. Okay? So then some people do patterns by assembling polygons, like puzzles. I can do the same. I can show you the same, how to make it. Okay? But this is not really. In Iran, you can also find a few methods. Some of them are older, some of them are newer, some of them are simplified, some of them are quite close to the original one. This is what you can find. And of course, I said you can find a number of simplified methods where people just know some properties and they are applying these properties. Okay. And finally, there are terms. Last time I was talking about terms and I told you about different terms. Normally, I prefer to use the term Gereh, not Islamic geometric pattern, not geometric pattern in Islamic art. For me, this is Gereh. Gereh, this is something that I use every day, and this is what I really like. Word Gereh means knot. Just literally making knots. This is the way how we build patterns. I will show you. So the whole thing is just about making knots. And I said also last time, in Central Asia and Iran, no one is talking about Islamic geometric patterns. They use term Giri, Gereh, like this. And this is where we are. So first we have to just think what we can call a method in pattern design. First, this is a kind of definition. A technique of pattern design that has some internal logic and clear rules. Okay? Not just, oh, let's collect this point, let's take this point, let's collect with this one, or maybe we'll get something. Oh yes, here's the star. Come on. That's not really a method. Method should have a logic, clear logic. So this can be a method. Assembling patterns by try and error, this is not a method. This is just making puzzles, okay? And then I said there are many methods. A good method is the method that can be used for the largest class of patterns. There are methods that are used for octagonal designs only. There are methods that can be used for decagonal designs only. But a good method will be able to be used for everything, almost everything. Okay? Now, the point-to-point method, you have at least two books. Islamic Art and Architecture, Issam El-Said. That is a very old book. You can find probably somewhere this book. Just warning. This book will not teach you a logic. This method will teach you how to connect points to get something. And it is really okay. It looks like this. Okay, let's take a hexagon, then they join these points. Okay, then on these points. This is what we hear during the first day. Okay, patterns based on grid. So here you are building a kind of grid, and then you're getting a pattern. Here is different way of making grids, and this is a pattern. Both books are like this. You can buy them if you have money to waste, okay? But you can look for something different. Grids method, I said. You hear this, you showed this already. Take, for example, here triangular grid, and then let's build a star, let's build something, okay? You're building some elements, and then you're taking this part, you're repeating, you're getting. Grid methods are quite fine, and there are really many patterns that you can make on grid methods. This is one of the oldest, really the oldest methods. Greeks were using this method. Then, during the first Muslim era, this method was mostly used in Central Asia, just different grids. But their grids were more complicated than this only. But this is fine. So, grids method, this is something that it is really worth doing because there are hundreds of patterns that can be used, made using grid methods. Now, you have example of pattern that was created using a grid method. Taking a square, dividing it into a number of parts. Here is 6 parts, 6 parts, 6 parts, and joining this way, just slant lines. And then you're saying, okay, that's my center, and then you start from the center. You build a swastika around, for example, this is just example only. And then on this swastika, for each arm you add something, you can do it on your own way. And then what you do reflection. You remember I was talking about reflection. Take this thing, reflect it down, reflect it left, and then this is what you're getting. And of course, coloring, you can apply misleading coloring. You see, coloring, it is for two reasons. Why? One reason is to make things beautiful, and another reason is to mislead people. So they will not understand what you really did, okay? So when they see something like this, they will say, wow, that's a great thing. And believe me, not many people will understand what happened here, how you got this. But this is a great method. This is really good method, trust me. There are many, many patterns that you can base on grids, and you can do marvelous things, and you can go far, far from this, okay? So that's a really good topic for PhD.
Can I ask one question, please?
That's really a good topic for PhD.
I think this is curved grid, and then is it aligned or something, some angles or something like that?
No, I don't care about angles.
It is something like aligned or...
I don't care about angles. This is what I said. I don't do patterns. I don't bother about patterns. My first step is geometry. Okay? When I have geometry, I can build on this geometry pattern that just I can get from this geometry. You will see later how it really works. The marvelous Hasba method. I have to go to Morocco and I have to spend the time to learn the Hasba method. Hasba method is really strange, but it works. The good thing is a Hasba method, it works. So what they do, they again take a square, in this case square, okay? They put a kind of grid, look at this, that's a grid. 4 lines, 4 lines, 4 lines. They put a kind of grid. Then they expand this grid by dividing some of the areas. And look how far they go. Okay. So these are their grids. Sometimes they even take 2 grids to overlap. You have here this example. And from overlapping these grids, they start drawing pattern. Look, you must have really good eye and good imagination to work with this, because you're getting this network and you say, okay, let's make a star here, okay? You have to see this star. Then you can say, okay, that's a nice petal, I can make it. Or that's another one, I can make it, okay? So the Hasba method is using quite a lot of your imagination, because, and you have to make it large. You cannot make it in a A4 paper because you will not see much, okay? And at the end, when you forget about all these grids, you're getting something like this. That is their pattern. This is typical outcome. Why typical? Because what they do, they very often take something like the drawing like this, they put it like you were doing with these papers and holes, they put it on a big plaster, gypsum, they stick the pattern on this, just using this device with the coal, black, okay, and then they carve this. The plaster carving in Morocco is like this. So they carve each element down, or other way, they carve these lines down and they leave these things up. This is Moroccan way, one of the Moroccan ways of designing their patterns. And usually most of their patterns are octagonal, just like this one. I am saying octagonal and you're asking why I say octagonal, because this is typical octagonal pattern, okay? 1, 2, 3, 4, 5, multiply by 4, which is 20. Here you have nice 8, okay? So everything plays the same game. There is only one paper about these patterns, only one paper. This is the paper wrote by 2 people from Morocco, and there's absolutely nothing. I spent really quite a lot of time looking for information and I couldn't find anything, okay? But you remember, these craftsmen are usually very, very secretive. They don't want to show how they do things. Then in Morocco there is a Zilich method. The Zilich method is using shapes that they know. So they have a number of shapes, and these shapes just they carved in tiles, just tiles. They carve them, and they carve them in a very primitive way, okay, just with the hammer, and then they stick them in the gypsum, put concrete on top of this, and they make large panels. This is the method where you know all shapes. If you don't know how the shape is built, you have to know each angles, each and so on. And you really don't need to know anything, because you have papers, you just put the papers, you draw on the tile the shape of something like this, for example, and then you cut, and you're getting this. Not much thinking. This is something that was developed a few hundred years ago and is staying without any change. Just playing with the puzzle of things. So, yes.
Question about this. With this method, since if you are working with this with predefined pieces, it's all at one particular scale.
Yes.
Doesn't there still need to be somebody who is helping to generate those patterns to be the correct size, or does that mean all of their work ends up being the same size?
This is how it works. They have a number of shapes. Now they use AutoCAD, okay, and they just, okay, let's go back, because you really need to see this. Okay, just let me to stop. No? Okay. This looks like this. In AutoCAD, AutoCAD is a computer program. Now, this is the way of designing patterns. In AutoCAD, they have all these shapes already done. Ismet Terzi is using AutoCAD and he has precisely the same. Okay? And then what they do, they take particular shapes and they just put them together. Okay? And of course, depending on this, which shape you will take, you will get something or something else. Okay? So from the beginning, you see what they're doing? The shape, by symmetry, each shape is going just around, okay? So this is what really they do. Okay? And now let's wait for a moment. Look what they do. Okay? They just prepare their tools, fine. Okay? And now, that's a tile, just a regular tile that you were using only with the glaze. Okay, and they cut it like this. That's the whole thing. Okay, so they get things like this. Okay.
For us, we were transported.
And their tools are really primitive. Okay. Okay, don't waste time. You don't need, and I doubt if you will be ever using this thing. This is from Facebook, and you can. Okay, don't work. Okay, so let's go further. That's how works the Zilic method, by knowing shapes. That is really all. Okay. For the Zilic, you can find 2 books. My favorite one is this, The Art of Moroccan Ceramics. It describes quite well the Zilic, and you can really enjoy looking at these photographs and so on. And this book is relatively cheap. This one is horribly expensive, and getting it is difficult. But if you will be lucky, it contains much more material than this one, okay? But you are not on the professional level at the moment. You have to start with something. Zilic method is fine, and you will enjoy it. Now, the standard shapes. Many people, what they do, they measure each shape. They go to the pattern in the mosque, they make a photograph, and then on the photograph they measure angles and so on. This book is like this. You see here it is saying G, G, E, E. Means this one, this shape is this one is exactly this one, so these 2 sides are equal. Here is 90 degrees, here is 90 degrees. Then you have angle number 6, and here there is a list of angles, so you know from the list what is this angle. So you're creating these shapes. Okay, this is like Zilic method, but it's a bit more creative. And that is really all. Okay, if you buy this book, you will spend a lot of money, and believe me, you will not learn anything. Okay, you will learn about the shapes. Okay, you will get a number of very good photographs from Morocco. But if you think that you will learn pattern design from this book, that's a mistake. Many books are like this. Okay, but that's how it works. Here you have Iranian simplified method. It is simplified method just taken by some observation. You see, when you look at the pattern originally, you see that, for example, you have pattern like this one. You see that some lines are just long. Okay? Here you're getting long line. Here you're getting long line. In some patterns, you can distinguish very nicely various type of lines. So if you take this pattern, if you divide it into 4 equal parts, if you start doing it, first is just to make this contour. Okay, you make a shape like this. It has specific proportions. You divide this angle into 5 parts, this one divide into 5 parts. Okay, look, proportions of this thing are established by division 3/5 of the angle 90 degrees to this point. Okay, so you're dividing this angle into 5 parts. You're taking the third line, you're going up to this vertical line, you're getting this point, and this is the shape. That's a proportion. And then what you do, you just put in the middle, exactly in the center, vertical line. Okay, you're finding points of intersection of these section lines with the vertical line. Okay, and then what you do, you draw circles. One through this one, another one through this point, and third one through this point. And then again, this one, this one. When you get this, you can start seeing your pattern, because you see here, you're joining this way. This is the point here. And then from here, you're going to this point. So you start seeing. This is more or less like in Hasba method, but the grid is much simpler and it's not really rectangular. So you're building your pattern on something like this. Okay? And then when you wipe out all these thin lines, if you take 4 copies, reflections, you get your pattern. You can make more reflections and you will get bigger pattern. There are many examples of this type of design in Iranian books. If you take any Iranian book, modern Iranian book, you will find such things. So these are traditional, but they are really simplified. For each pattern, you have to work out again. You have to find out some hints, some lines, and then. This is not really a general method that will work for many patterns. It will work for this one, or maybe for another one if you start making something. Then you have the whole Russian world, but all this is collapsed at the moment. Shortly before the Second War and after the Second War, there were Russian dissidents, really dissidents, that were sent to Uzbekistan, and they were taking part in excavations, they were writing papers, they were doing research and so on. And one of them is Rempel. That's a very good book. I never had power, enough energy to read the whole book, such a book, and you really have to spend time. It is a very difficult book for reading. I know Russian well, but even this one, simply, it is hard book. Then is Bulatov. Bulatov, he has mostly plans of various kind of madrasa mosques. He has a nice chapter about patterns, and most of the basic patterns are precisely well done. The advanced patterns, he messed up, okay, but this is the life. Trust me, I don't know any book about geometric patterns without errors. I don't know any. Then you're getting something that is on the net, but you have also to have patience. Tony Lee he's former engineer. He's not mathematician. He was like many of you. He was passionate about patterns, he was traveling, and he was trying to set up a number of sketches on the geometry of patterns. If you want to learn from this, you will learn quite a lot, but this is not the material for the beginners. This is the material that you can take a page, sit down, take your tea or coffee, and look at the picture, read a few sentences and try to figure out how you can work with this, okay? This is nothing that you can do step by step. This is his private notebook that was copied by somebody, just scanned and put on the web. So that's not really a printed book, okay? I like this thing. Honestly, I like this thing. I printed for myself the whole thing. I have it at home, 2 big folders, and quite often I am just running away into this book. But this is like really running away. You're going into something and you forget about the rest of the world. It doesn't exist. Okay, I wish to go with you through Gereh. A typical Gereh method that was developed in the 12th century by some kind of evolution. You can find that many of the earlier patterns also can fit into Gereh, but this is again long work. This is a pattern that we call carpet type pattern. You can find these patterns in Istanbul. They are like carpets. You can use them to cover the whole world, okay? But you still remember, in order to do this, you just need a quarter of it, not much. Okay, so they cover the patterns like carpets. Then out of this you can get friezes. Very often we need a narrow pattern just to border something. This is a typical collection of friezes. This is from Cartagena, and here you have a frieze. Here you have another. Practically every geometric pattern can be used to make a frieze. Fragment of a geometric pattern can be used to make a frieze. So this is second type. And the third type are various kinds of rosettes. And here you can be absolutely sure. Rosette was invented by the mathematicians from the Muslim countries. Okay? This is a typical Muslim heritage. About many patterns you can say, oh, that is Japanese, or maybe this one from China. With the rosettes, you have no question mark. These are the patterns that were developed in the Middle East, mostly here in the Middle East, Central Asia, Middle East, Iran, Egypt. Okay? This is what you will find in Egypt, in Morocco. This is usually a copy of this that was done here. There are very few original patterns with rosettes in Morocco. But remember this example that I was showing you. The typical form of Morocco are the huge rosettes with 48 petals, 64 petals, okay? That's a Moroccan invention. But you can find also patterns like this in Konya. Now, let's go to the past. There is a word, Daftar-e-Gereh. We don't have Iranians, they are gone. What means Daftar-e-Gereh? I explained, word Gereh means pattern. Daftar means a book or notebook. So this is a notebook with patterns. And Daftar-e-Gereh doesn't look like notebook. It is long piece of something. Usually this is good paper or bad paper also. And it's scrolled. You have 2 pieces of wood at each end. It is just scrolled. It looks like something like this. Only just the length is huge. And what you have? You have famous Topkapi scroll. 33 centimeters like this. 29.5 millimeters long. It is huge. Okay. It has 114 examples of patterns from Timurid dynasty in Central Asia. And its age is 1350. Okay, the patterns are from this period. What is really Topkapi scroll? Topkapi scroll was a gift to the Topkapi palace, to one of the sultans, from the architect from Iran. Okay, at this time it was Ottoman Empire. So this is a gift. For this reason, this scroll is well made. All patterns are really well made with hard ink. Okay, and there are not many, let's say, not mistakes, but let's say bad points in them. It is perfect drawing. Then you have Mirza Akbar Khan scrolls in Victoria Albert Museum, and they were done, bought in year 1876 from the wife of Mirza Akbar Khan. Mirza Akbar Khan was architect. He was a main architect in Iran. And he was collecting various patterns, and these are his scrolls. When he died, his scrolls were bought and then were deposited in Victoria Albert Museum. You can get to them, you can really explore them if you are in London. And the difference between Topkapi scroll and this one is that Topkapi scroll you cannot see, you cannot touch, it's out of your hands. Forget. I was trying to do many times and I never succeeded. Okay? But you can find on internet photographs of Topkapi scroll which were taken from a book Topkapi scroll, so you can find them. Mirza Akbar scroll you can touch. You will get rubber gloves, you will get pile of papers, and you can touch them. No problem with this. This is the difference. You can examine them, you can do research on them, that's fine. Another difference. Topkapi scroll, I said, this was gift for the Sultan, so it is perfectly done. In these scrolls, you're getting sketches. Sketches, they are not accurate. Simply, you know, if you are an architect, if you are dealing with these things for many years, you know things, okay? You just draw a few lines and you know what is this, okay? No one else will know. So many people complain. It's not accurate. This is wrong, this is wrong. I'm not saying this. I can restore each of the patterns from Mirza Akbar scroll and I have no problems with this. Until now, I was able to do practically all of them, okay? Then you have scrolls in Uzbekistan. And this story is quite complicated. I have 8 inventory numbers from Bukhara Museum, and I know these scrolls are there. When I go there, they say, no, we don't have anything like this. Come on. Okay. But for sure I know that there are 8 scrolls. But there may be much more, because when you read a Rempel book, in the Rempel book you will find information on the scroll from Samarkand or the scroll from somewhere else. There is a picture like this. So there are other scrolls, but where they are and so on. These scrolls were bought by Andreev. He was professor of linguistics. He was not architect, he was not mathematician, he was really not interested in patterns at all. He was linguist, he was in Bukhara, and he bought these patterns, these scrolls literally from his own pocket, and then his wife gave these patterns to the museum. And in fact, there is a short paper by Andreev, which is just description, what is on each scroll. So this is the reason why I say there I have 8 inventory numbers, because inventory numbers are on this paper. So I know this for sure that they are. This is the picture that you get from the Rempel book, and this is the photograph of one of the scrolls that Rempel found. What a good thing is, there were different methods of making these patterns. Some of the architects were drawing them using pencil, and then the real pattern they were painting by, let's say, ink, and then they were wiping out pencil, so on. So there is no shade. Here, this architect was using hard something, okay? You can take, for example, hard piece of metal and ruler, and you can just make a line, okay? The line will be only impressed, and it will be not really well seen. So Rempel took a camera and took the side light. The light is going from the side, so he could see these lines. And this is the only photo showing how the pattern was constructed. Look at this. Dividing angle into given number parts, going to here, dividing this point area into a number of parts. Then again, somewhere here you have again divisions. And then when the lines meet, okay, he's just constructing just a regular, a kind of pentagon. You see the pentagon here? It is there. It was constructed before the pattern, not after the pattern. Many people telling me, oh, this was after the pattern, it was added artificially. No, that's not true. This is before making pattern, okay? So it is here. These polygons are here. You can see this, okay? If you print this, and then you will be able to see it better. If you have Mirza Akbar, yeah, that's from Mirza Akbar's scroll, but this is a reconstruction. These lines that I was showing you, you cannot see on Topkapi scroll. Topkapi scroll was done in such a way that there is no shadow of any construction. These are just patterns, okay? And you have to be clever architect to know what is there, okay? This one is not. This is reconstruction from Mirza Akbar's scroll. One thing that you can notice everywhere, on every scroll, every pattern is rectangle or square. There is no single, okay, there is one triangle, which I found one triangle only. Okay, most of them are rectangles like this. And how you can make your own pattern on this? By reflections. If you have this is the same, you can reflect and you can get something that looks correctly, okay? You cannot do like this, you cannot take this and move it here. Forget, because you get these strange places and this is really bad. You cannot allow the pattern will look like this. And more, if you are Kundekari master or if you are doing carving in something, how you can carve a shape like this? Come on, there's no way, okay? So you must get nice polygons. If you don't have these polygons, sorry, you have very hard work. So that's the first thing, correct way. Lines must match, and that is extremely important. And out of this template, the thing like this I call template, you can create really a few patterns, because if you start turning it to the right, down and left, you're getting this. But if you start doing this opposite way, okay, then you can get this thing. So instead of making to the right, you're making to the left, okay? And you can get this. Each pattern has really two faces or three faces. That's the one face and that's the another face. Very often on Kundekari doors, in the bottom part, you can find patterns that have strange look. They have rosettes in the corners, and in the middle there is something different. Each pattern can be used to make two patterns like this, or think like this. If you take more copies, you will get something that will be big. So depending on the space that you have to cover, depending on the space that you're covering, You can have more copies, less copies, you can have parts of this and so on. For example, listen, you can cut part of this, for example, like somewhere here, okay, and you can use this part to make another pattern. Reflections only. Sometimes you will succeed and you will get something nice. Sometimes it will be looking badly, but this is this. On some patterns in Topkapi scroll you can find red lines. What are the red lines? If you go back, you have white lines here, okay? That's our white lines. On the Topkapi scroll, these white lines were marked using red color, okay? And many people are telling me, listen, these red lines, definitely they were added after the pattern was done. And I'm saying nonsense, okay? These lines really are useful for making patterns, for creating patterns. And I will show you why. So what you have here, the red polygons, in the Western terminology, they call usually tiles. Sometimes they call about Gereh tiles. Okay, I really don't like this because they made mess up with this. This is Gereh network in Russian books. Okay, usually when I talk to the Iranian architects who are working in this, they say that's a Gereh tessellation, all tiles together. So the red ones, okay, the white, the black one, this is the pattern. And you remember I said I don't make patterns. I grow patterns, because if I have these red lines, using these red lines I can make a lot. I can make many different patterns, no problem with this. So let's look on rules. Over the years I was gathering some conclusions. Then I came to the idea that some of my rules may not be really accurate. So I adjusted them, but at the moment I have a reasonable set of rules that I use. So usually tessellation tiles are convex and symmetric. By tessellation tiles I mean the red polygons. Convex, it means like this, no gaps in. Okay, so they are convex and symmetric. Usually, all of them, usually, not always, that's a symmetry line, mirror symmetry. Here, if I am not mistaken, this is a symmetry line. Okay, this thing, what is this thing? This is part of something. 1, 2, 3, 4, 5, 6. This is part of the decagon, and here you remember there are many symmetry lines. Okay, dodecagon has 12 symmetry lines. Fine, and we like this. So remember about this. Tessellation tiles are convex and symmetric. Sometimes, not always, you will get tiles that are not symmetric, and this will be different world. Different story. Every tessellation is edge to edge. It means if you have these two tiles, they have common edge. If they have two tiles, they have common edge. The whole edge is common, the whole segment, okay? Not part of it. The whole, again, I said that's a conclusion by looking at many examples. But you can always find something that was created differently. But anyway, these tiles are always edge to edge. There are no gaps between them, and there are no overlaps between them. They are just tightly covering the whole thing. Sometimes you're getting half of something, okay? Here, for example, you're getting half of pentagon. Yeah, 1, 2, 3, 4. That's not regular pentagon, but you don't need to bother in this moment. Tessellation polygons are complete, or they cut by the edge along the symmetry line. So this one is complete here. This one was cut by its symmetry line. It is here, and the second part of it is on the side. This one, that's dodecagon. It was cut by symmetry line, and the other part is here. So always look at this from this point of view. Edge is important because edge is dividing some of the tiles according to their symmetry. Then next one. If a single line of a pattern touches the edge of the tile, then on the other side there is another line going into a mirrored direction. Okay, let's look at this where I have it. Okay, single line, single. Okay, that's a good point. Look at this. Here's line going to the edge, and on the other side, this angle and this angle are perfectly the same. Okay, so this line is really, the red line, is really a reflection. That's a mirror. Whatever is coming to this place, it has to be mirrored like this. What about two lines? With the two lines, when two lines touch the edge of the tile, then they continue on the other side without changing direction. It means angles are the same, and without changing direction or stop there. This thing I added just recently because I found that some of the patterns are like this. That's number 5, and this is here the rule 5. You see, this line is going and is continuing. This line is going and is continuing. This angle, this one, and this one are identical. This line is a mirror, perfect mirror. But recently I found a Gereh where the two lines are going to the edge and they stop here. So you're getting such a thing. Okay? So I added this part because it is worth to be accurate. But just remember, angle, 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 angle. These angles are equal. You cannot have different angles here. They must be the same. Why? Because if one of these angles is different, then you're getting something like this. One line is going this, and the other one like, it looks ugly. Okay? That's against our aesthetics. So for this reason, these two angles must be perfectly the same. Okay, we have rule G5. Here I wrote this. Lines inside of the tessellation tile connect in places where their directions intersect. Look at this. One line is going from this side, one line is going from this side. You may be sure that these angles are the same, okay? They meet here, and you can stop them here, okay? They don't need to go farther. Or, if you like, you can just follow with this line, take this line, follow here, and make something like this here. That's really up to you. But these points here are the points where two directions meet perfectly. Sometimes you will have to make these broken places on your own, and you will have to decide how you do this. And then you will have few ways of doing this, and each way has something important. This is what I added recently because I was thinking always, this is obvious. Lines of the pattern do not stop inside the contour. There's never a place where a line is going and suddenly stops. Okay? If they stop on the edge. They stop on the edge, always on the edge. But this is just a trivial construction. And the last rule, which is quite interesting and worth remembering. For each tile of the tessellation, pattern inside of the tile has the same symmetry as the tile. It means you have this dodecagon. Dodecagon is dodecagon, which is 12 symmetry lines, and this pattern inside it is again 12 identical petals. Okay, so symmetry of the pattern inside of this tile and symmetry of the tile is the same. But if you make exception, you can get something like this. Look at this. Symmetry of this thing is different than symmetry of this thing. How many petals we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It means there are 20. Okay? So this is 20 gone. But this pattern inside, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? We broke symmetry. The symmetry is broken. But as a bonus, we got something that is completely different. Okay? Otherwise, we could have something boring, long lines going through it. But if you break symmetry, sometimes you get something interesting. And what I make here, in this place, I wrote, each rule can be ignored if this makes sense. Sometimes you can say, okay, let's make something different. Okay? So, for example, just imagine you have this pattern, and you say, okay, forget about this. Forget about these two lines. So what will happen? You will go with this one, they have to meet somewhere, okay? Then, you're just doing, fixing the place. If you don't have this and this, and then, of course, you have to do something with this, so you have to draw like this, and you can eliminate this part. You can make a gap here. If you will make a gap, you can also make a gap here. Why? Because if you skip these two lines, you can put like this, okay, and you're breaking symmetry. Here you're really not breaking symmetry because there's only one symmetry line. Here you're breaking symmetry because you have 12 symmetry lines, and some of them will be not working. So you can break symmetry, and every time when you're breaking symmetry, you can get something that is really interesting. I can show you one pattern that I recently made, very recently. Okay, now let's go. Okay, that's the one. This is the pattern that was made precisely using these rules. The only thing that I did, I broke symmetry. For most of the tiles, I broke their symmetry, and I got something like this. How you like this? It's regular, it's terribly regular. People were trying to find that this pattern is irregular. No, it is very regular. It is a random pattern. It is random pattern even. But here you have sometimes some elements symmetric. For example, the blue one and the white one on the side, they are identical, but you have to rotate in order to get them. This one is symmetric, this one is, but this one is not. So I broke symmetry and I got something like this. So you have these things, and every time when you break symmetry, you're getting something new, absolutely new. Okay? I'm not sure if you know this thing. Okay. On the Facebook, I made a page with the name Symmetrica, and from time to time I put there something, okay? Not always, because often I forget, okay? But you can find there quite a number of patterns that I made recently. For example, like this one, like this one, like this here. I really like modeling doors from Istanbul, from Ottoman period. I made them quite a lot. Okay, that's another example that you have here. You will find them quite a lot. A summary, important summary. Before you decide to make a pattern, you have to make a right contour. Like I said, you have to make a right space, right plot, okay? Then you have to construct tessellation on it. standard tessellations give you standard patterns, but the pattern from the Topkapi gate uses non-standard tessellation and it's absolutely beautiful. And then when you have tessellation, you can make template. When you have template, this is this rectangle, you can make a pattern and you can make a number of copies and three steps, step by step. Okay, so that's the whole theory that is here. And I will show how it works in a real example, and I have 20 minutes for a real example, but before this, I just want to show you something. Some time ago, I made this thing, okay, it is in Polish, sorry, okay, this is the collection of papers for maths teachers. I do it for maths teachers, okay, and it has quite a lot of these methods there. Okay, so you can look at this. If you want to buy it, if you are brave enough, okay, then you can go. This is so-called book depository. Book depository. This is international bookshop like Amazon. And they have all my books there, not all, but at least the last ones. And what you have there, the first one that you will get is this. It costs you $17 with shipment. Okay, this is with shipment. That is important. It is with shipment. Okay, so you can buy it from them. That is fine. They advertise that this is for shipment. These my older things, okay. This is more about geometry, real geometry. This is general about art and geometry, okay. And then there are other things that you really don't need. This is programming book, and there are some programming books below. That's the one. Description is in Polish, sorry, okay, but you can see how it looks. $17, okay. Free delivery. Now, let's go. Let's do something real. You use your pencils and paper. I use my computer. I don't do anything different, anything that you do. Precisely, I do exactly the same what you do. I draw segments. I make lines perpendicular. I copy things and so on. So, very briefly, I will show you something, what I do. And then I will show you one of the examples. For example, how to divide a segment into two equal parts. Very basic question, okay? Draw a line. Then what you do, you make one circle and you make another circle, okay? So this is what you do. Okay? And then what I do, I draw a line like here, then I mark this point, and then what I do else, I just take this thing and I ask to hide them. This is like using rubber. Okay? Hiding is like wiping out. So I got a middle point. Okay? Other tools, you can do quite a lot. For example, how to divide angle into two parts. That's simple. Okay, suppose that I have two lines. One line is going like this, one line is going like this, and I had to divide this angle into two parts. What I do, I take a circle, any circle. I don't need to bother too much about this. Then what I do next, I make one circle, another circle, and then I draw a line from here to here, and then I don't need all these circles, so what I do with them, divide, hide circles, and I divided my line. This is what you do in the school. When you divide angle in two equal parts, you do precisely the same construction. Nothing different. There's absolutely no hocus pocus in this program. Okay? Everything is going precisely the way like you do on the piece of paper. Perpendicular line to a segment in a given point. Okay. Perpendicular line to a segment at its end. Okay, that's a nice construction. I really like it. Okay. You have something like this, and you want to make perpendicular line to it. How to do it? Just do it simple. What you do? Make a circle, any circle. It doesn't matter what is the size of the circle. Then you do another circle. Then you're taking from here to here. You make another circle, okay? And then what you do, you just draw the line. You're getting precisely this point, and when you connect these two things, you're getting a right angle. Nice construction, okay? So you're getting precisely a right angle here. And of course, I can do it using other tools, but if you want to be very classical, you can do it in a most classical way. Parallel line to a given line, you can do it the same. Dividing line into given number of segments. That is something that is really useful. You have a segment, and you have to divide it, for example, into 5 equal parts. And everybody in this moment say, 5 equal parts, how can I do? I know how to make 2. Or maybe I will know how to make 3. But 5? That is simple, okay? So what you do? Okay, that is precisely this. You have your segment, okay? This is old construction. This construction is probably from the 10th century, from the mathematics in 10th century. Not many people remember it, okay? You will not find it in geometry books, really. Okay, so what you do, you just take this point and you draw a line. It doesn't matter how far is this line going, okay? And you don't need to bother about this. Just any line. It can be like this, like this. That's really up to you. And then what you do, you start drawing circles. One circle, then another one, then another one, then another one. How many of them? 1, 2, 3, 4. One more. Another one. Okay. Mark this point. And then what you do, you just have to say this. Connect this point with this one. And now take each of these points and make parallel line to this one. You know how to make parallel lines, okay? I didn't show you, but okay. So construct parallel lines, you got it. And then you got these nice points, okay? And what you do, you just say, okay, forget about this. You got division of a segment into 5 equal segments, okay?
Could you please show your parallel line method, how you make?
Parallel line?
Yeah, please.
Okay, let me to go to the right page. I don't wish to mess up it here. Okay, you have a line and you have a point. The problem is always find line passing through a given point and it's parallel to this one. Okay, let's make it closer because otherwise the picture will be too big. Okay, so what I do, I just take a point here, any point. You can always take any point on the line. Okay, then you draw a circle through this your point. Okay, this is the point through which you want to have it. Then what you do, okay, you just making a segment. Then you make center of it. Okay, you know because I was showing. And then what you do, okay, and then you can use For example, something like this, and then this point, okay, not this way, this point and this point, that is parallel line. Simply what I created rhombus. That is rhombus. I didn't fill it properly, but my rhombus looks like this. So parallel line, this is really rhombus. You can do it different way. That's up to you. Okay? Okay, let's go to the end. I wish to show you something. Okay, I wish to show you something that is quite nice. I have a drawing of this, and you can make a photograph, okay, because when I will start drawing, I will not have names for the points, so you can photograph it here. Okay, that is something that is really important for us at the moment. I talked, when I was showing examples, I talked about dividing right angle into a given number of parts. Okay? With decagonal patterns, you have to divide right angle into 5 parts. Okay? How to make it? What will be the parts? Look at this. If you calculate, okay, 90 divided by 5, this is 18 degrees. Okay? Here is nice construction. I will show you step by step how it works. So I have like this. I have my segment, okay, and I know how to make perpendicular lines to it. Okay, why? Because we did this already. So that is fine, okay. Up to this moment, everything is perfectly fine, okay. Now, how to divide this angle into 5 equal parts? What you do, you just start by doing something like this. Make a circle, really any circle. You don't need to bother about size of this circle. Then what you have to do, you have to, okay, I just prepared this thing because you have to find the center of this radius, okay? When you find the center of this radius, you're making another circle precisely like this. Until now, there is nothing tricky. You agree with me? So what is your next step? Next step, you take this point, connect with this point, and then you just mark this thing, okay? This is just fine. You're just making a circle through this, okay, and then you're getting this point. I always miss this thing, okay, and now you got what you wanted, okay, and this angle from here, okay, from here to here, is 18 degrees. So that's the simplest construction of the angle 18 degrees. Then the rest is fine, because you don't need all this stuff. So you can say hide them. Okay, you don't need this, you don't need this, you don't need these things. Okay, and even this one, and even this one. High points. You got the right angle. And what else you can do? Make a circle, and then with the small circles you can mark points. 1, then okay. I don't need the last one. And then lines. This is how you divide the right angle into 5 equal parts. And then you can build your pattern on this. Yes, do I have everything prepared? No, I have to copy this. Okay. This is the page number 9. I don't need all this construction. I need only this, what I have here. Remove everything. Remove everything. Now I don't need these circles, so I can wipe them out. Okay. I don't need these points even, okay, but I don't wish to waste my time. And we are ready to do something real. For example, just I say for example, take this point, make the line that is perpendicular to it. Okay. This one, precisely the same. Precisely the same. You can divide this angle into 5 equal parts. I will just use shortcut, okay? Rotate it 18. Okay. Then take this one. Okay, it is like this. So I divided both angles into 5 equal parts, and now I have to make it bigger because otherwise you will lose your eyes. So, okay, just, okay, look at this. You're getting a grid like this, and you can use this grid to make your tessellation. That is simple. Look, if you look at these matters, you see already what is happening here, okay? You see already, because for example, you have point here, you have point here, so if you make a circle like this, okay, or maybe, that's fine. Distance from here, okay. Okay, let's go to this point, make it red, make it thick. Okay, then make it like this. Then what you can do, if you got this, you can just make a circle, and then you can make things like this, you can make things like this. Okay, precisely the same you can do on this side. Okay, and then you can make another circle here. No, circle, come on. Like this, okay. And then you're building the rest of the tessellation. From this point to this one, to this one, and that is missing here. I only have to do something with this, so I just take this one, lines perpendicular to this, okay? So I have these 2 points. I don't need this. I got my tessellation. As soon as you have your tessellation, you got your freedom. Out of this, you can do whatever you want. For example, for each of these segments, you can mark a center of it. Why not? Okay, I didn't mark it. So construct midpoints. Okay, I need also a midpoint to here. So that's the one. And now look, the simplest pattern. Just connecting centers, just like this. You got it. Okay? And the rest is going. You remember the rules. Now, using the rules, you can expand this pattern on the rest of the thing, because what you can do, okay, just make thin line. Okay, look at this. And then what you can do, you can start marking the rest of the pattern, just like this. Just like this. So you're building your pattern step by step, step by step. Okay? I know that this is too fast. And I know that I should finish 4 minutes ago. That's the whole freedom. I said, put the seat. My first line that I put here, this is your seat. And then the pattern grows on its own. You don't need to even do anything. Just allow it to grow. And then the same you do on this side. Look at this. Here, how to fill this. That's easy. Okay? Because what you can do, again, you just take this thing, just like this. Make the line thin. Okay, this is just a pencil line. Okay, and then, for example, this one you can finish in some way, but at the moment I don't need to bother much. Okay, so I got it. Okay, the same I do here. In your case, if you have pattern like this one, it is simple following lines. If pattern is getting complicated, what you do? Tracing paper. You don't need to make everything from scratch. For example, suppose that you made something in this pentagon. You take a tracing paper, and if you have more pentagons, you just move your tracing paper, you copy, 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 and you're building your pattern without any effort. This is what I do with this tool also. I have opportunity to copy fragments, and I often make it, okay? So, for example, instead of, okay, just do I have this tessellation separately? No. Instead of something like this, okay? I have everything what you see here, I made for myself, okay? Okay, suppose that I wish to, no, this will not work really. Yes, okay. Okay, suppose that instead of shape like this, I want to have a star like this. Does it work? That's my tools. Over the years, I created a number of tools that will work for me. So instead of this, what I did here, I can make a star. And again, remember axioms? Lines must follow. This line will go this way, okay? And you can build your pattern quite quickly. Okay, that's all for today.